What's the do you have it open on your phone, please? What's the ID number for this one?
112.
112.
Number 5 is 112.
Okay, great. Now the reason I asked for the ID number in the database is the ID number never changes. But if I delete a question, then obviously the question number changes. But the ID number never changes. Okay. Right. So, Marwan, do you mind reading the question to me?
The tennis ball traveling in a horizontal direction with a velocity of 20.5 meter per second
Okie dokie.
is hit back in the opposite direction at the speed of 40.8 meter per second. The ball has a mass of 0.0591
0.0591 kilograms, okay?
Okay. Determine the change in momentum of the ball.
Okay, so the change in momentum, you know the story, don't you? MV minus MU, that'll be minus 40.8 times 0.0591. Isn't it? Minus 0.0591 times 20.5. Now don't worry too much about the minus. The reason I have minus is because I said the tennis ball was going to the right at the beginning. If you're Arabic and you said it was going to the left, then that's fine too. Which way did you draw it, or did you not draw it? No. But if you were to draw it, would you draw it going left? Oh yeah, no I know, but naturally what would you do first? Would you draw it left or right? Left. Oh, good man, okay. Right, so what number do we got here?
3.62.
Sorry, say again, Peter?
3.62.
3.62 kilogram meters per second. Okay, I assume there's a second part, is there?
This one is
If the ball was in contact with the racket for 30.4 milliseconds, determine the average force exerted on the ball with the racket.
Okay, okay, so what formula is that now, guys?
The change in momentum.
Yeah, delta P over
Change
delta T, yeah. So let me see, that would be minus 3.62 over 30.4 times 10 to the minus 3, because it's milliseconds. Oh, sorry, I wrote, oh, no, that's right, milliseconds. There you go. Okay, when you're ready, you can tell me what that is.
goes minus 107.
107, like this? Newtons. Grand. Is there more to this question?
No.
No. So a couple of people were asking me about this. Were you one of them?
Yeah.
Yeah, and someone else was asking me.
The confusing
Yeah.
stuff is still the initial and final. That's what made me feel the question.
Oh,
Okay, I've seen I made a mistake. I put the 0.05.
Me too, my final velocity was 20 and my initial was 40.
that's not as bad as it sounds. It just means the sign is different.
Yeah, no, but my final answer was minus 1.19.
Here?
Yeah.
Ah, so your problem is not mixing up initial and final. Your problem is not having the right signs.
The final.
Because even if you mixed up initial and final, that's actually alright because the sign would just be the other way around. So you should have had a minus and a minus, or a plus and a plus. What did you have?
Oh,
Just do a
the question.
plus plus.
The final answer is wrong.
Oh, this isn't 3.62. Who told me 3.62? Oh, this one isn't 107, right? What is it?
119.
119.
Minus 119.
Yeah.
Okay, fine. Where is Ming? Does anyone have a WhatsApp message from her? No? Son, is that a charging pack? A wireless charging? And does it work with only some phones or any phone?
And NFC phone. And
Oh.
phone that allows it.
My phone doesn't have that. Any NFC phone?
Not NFC.
What's it called?
Wireless charger. No wireless.
Oh, okay.
NFC,
No.
It's the near field
something.
something. Yeah. Alright, what's the next one?
Still 6.
What's the ID number?
212.
212. Well, Ming, why are you so late? Because the wind. Because the wind. I don't know if I'm happy with that, Ming.
I promise not be late last
Next
time.
time, not last time.
This is the last
Just so you know, because it hasn't really happened yet, but when students are more than 15 minutes late, I don't let them into the first class, okay? So,
She's 12 minutes late.
yeah, so she was just about on the right side of it, but 15 minutes and then you have to come in for the second class instead.
So what is my second class? Like second period or the second day?
Second period.
For second hour.
Yeah. Yeah. All right. 212. Rahman, maybe you could read it to me, please, if you have it on your phone. Yeah.
A single force of 5 newtons acts on a body of mass 8 kilograms for 3 seconds. The body was initially at rest. Determine the acceleration of the body due to the force.
Good old Newton's second law. So you want the acceleration, you say? Was it, Rahman?
Yeah.
So that would be 5 over 8, which is 0.625? Right, what's the next part?
Determine the change in momentum of the body.
Well, that's good old delta P over delta T.
Yeah.
So delta P equals F delta T, which would be 0.625 times 3, right?
No, F is 5 newtons.
5
Huh? Oh, sorry, I put in the A, didn't I?
Acceleration.
Yeah, so that's 5 times 3. Well, that's better, because that's easier. It's 15 kilogram meters per second. Yeah?
I got that, but I did it at a different.
That's fine. Let me guess. You calculated V.
Yeah.
Yeah, okay, yeah, fine, yeah. Longer though, huh? Yeah. Right. What's next? Is that what you did too?
No.
No, okay. What's next in the question?
That's it.
That's it? Okay. So what did we do so far? 5, 6, and you said 7, Danny, didn't you? Yeah, what ID number is that, Danny?
7, the
4,
issue
5,
is not
4.
really that we got the wrong answer, it's just how did we get the answer.
Huh? Wait, what's going on? I'm sorry. My brain couldn't process the two conversations at one.
Yeah,
Wait. Danny was telling me something, I think, and then
No, he was speaking for me. I was asking if it's fine and I heard.
he's speaking on your behalf.
Yes.
Okay, fine. Continue speaking on his
Yeah,
behalf.
the
What does he
issue-
want me to know?
The issue is that it's not that I didn't get the answer. What I
Yeah.
didn't understand was the time.
Yeah,
After you get the first question
Yeah.
was the initial momentum,
yeah.
then they now asked them the first.
Well, the first question was the acceleration.
Yeah.
Yeah.
Calculate that.
It's number 7 I'm asking.
Oh, okay, sorry, we're on to the next one. 454, right. Well, is it the case, Danny
Yes.
and Bello, that you don't need to see the whole question? You just have a question about part of it, is it? Or do you want me to do the whole thing?
Sorry?
You want me to do the whole
you can
thing?
do the whole thing.
Yeah, I think it'd just be easier if I do the whole thing, and then you can ask me the question as it comes up then.
Mm.
Right, so Bello, could you read 454 to me, please?
A garden hose is used to direct a stream
Okay.
of water on a wall onto a wall. The water is initially moving at 5 meters per second before it hits the wall and comes to rest. 1.2 kg of water leaves the hose per second.
1.2 kg per second.
Okay, I think this is where the confusion comes, like the kg per second.
Mm.
So what's that?
Huh? 1.2, is it? Kg per second.
Yeah.
Now, let me just, before I continue, right, I just want to explain what I'm thinking about this. Because it's 1.2 kilograms per second, I'm picturing the water as moving in 1.2 kilogram blobs of water, if that makes sense. It's almost like every second I imagine a 1.2 kilogram mass, a body of water coming out the hose, if that makes sense. And that blob is moving at 5 meters per second. this should remind you a lot of the rocket question. Instead of gas, it's water. So, anyways, what are they asking us here?
What is the initial momentum of the water hitting the wall each second?
Okay, so the water, just before it hits the wall, like let me say like here, for example, its momentum would be mu, which would be 1.2 times 5, which is 6
Yes.
kilogram meters per second. Now, are they going to, per second, sorry, are they going to ask me what is the momentum after it hits the wall, or is that too obvious?
No, it's not.
The force.
What's the force acting on
Acting
the
with the
wall?
wall.
But what is the momentum after it hits the wall?
Yeah, I might as well write that down. I'll call this P1, and then let's say here it hits the wall, P2. What is the momentum there?
The U is 0. So
Yeah, 0.
But there's like a part of the question that says like, what about
Ah, who's
special-
this now?
Hello.
Ah, you're coming here to do some physics.
I'm not, but Aoife is.
Oh, good. She
So-
might do a bit better of a job, would she?
Than me? Oh no, I'm okay.
All right, great, wonderful.
Physics.
Aoife, you'll have to squeeze in
There's one over
there, I suppose.
So, can you chat to Aoife afterwards as well about maths and physics and just what to kind of expect a little bit, just to give her an idea?
Yes.
She just tried to give for today.
Okay.
And
So we'll all have to give a good impression, the whole
Yes,
class.
yes,
Yes.
So we have to do
Okay.
Yes, we've doubled the number of girls in the class. It's exciting.
So, I'll talk to you later today, Aoife, okay?
Okay.
Thanks.
Great. Okay, Aoife, so what we're just doing this morning is we're running through some problem questions we had with homework last night then. Yeah?
No, like she has missed a lot.
She did miss a lot, but you don't know, she might be a genius.
Well, I'm the class rep,
So what are you trying to say? You're the genius?
No, I'm the class rep, like if you need anything. Everybody is
Let's continue, so. What was it saying? Oh yeah, so the momentum after it hits the wall will be 0. Who was asking me that?
Was
it was still me.
It was you, Bella, okay. Is that okay? Yeah, now let's continue with the question. Who was reading it? Bella, were you? Can you tell me the next part?
What is the force acting on the wall from the water?
Right, so what formula could we use
F
here?
is equals to mv minus mv.
Yeah, you have two formulas. Delta P over delta T. Or
Equals to mv.
F equals MA. But both of these kind of have a problem. Like, what's the problem with using this formula?
Time.
Exactly. So can we use it? Not really. Because we don't know the time. Do we? Do we know the time? Is it given?
Per
That's
second.
kg per second doesn't tell
Oh,
us
good.
the time.
Okay, fine. Yes. Okay, you can think about it like that. I wasn't sure if you would. You can think about the delta
Yeah,
T
that
as
was
1
my
second.
confusion.
Yes, yes. I would have thought about it differently. I would have thought about it like this. Or the force is equal to mgvg.
You.
Yeah.
That's complicated. The question is saying like 1.2 kg of water leaves the hose per second.
Yeah.
Something like this.
Yeah.
So the time is 1 second.
Yeah, that's fine. But
Yeah,
remember
that's-
how we got this formula? We got this formula from this formula, remember?
Yes.
And what did we say the time was in this formula to go from here to here? 1 second.
1 second.
So, you can either use this formula and say delta T equals 1, perfectly fine, or you can use this formula and just directly multiply these two numbers. Also perfectly fine. Both are acceptable here. Okay?
We are
So
supposed to put
either way you get
MW,
6 newtons.
MW, not mg. Mass of what actually?
Yeah, I wrote G because that's how I wrote it
Okay,
in the
gas.
formula. But guys, I don't know if you've ever seen this video. That formula I gave you with the force equal to the mass of the gas times the velocity of the gas. That's for a rocket, right?
Yes.
But it doesn't have to be gas, it could be water. Do you ever see that video of the guy with the jetpack over the lake? And the water is shooting out of the jetpack?
Yes.
Same formula. It doesn't matter if it's water or gas. Do you understand? It works for both. Same way. Yeah? But I think gas obviously is more convenient because you can put a lot of gas into a small container, but you can't really put a lot of water into a small container. Yeah? Right, is there anything else from the homework then?
Yes.
Yes.
Okay, great.
Number 8 at all.
What,
Okay,
I-
sorry, the number 7, the C2.
Oh, there's one more part. Okay, what's the next part?
7C.
Hang on. Danny, could you continue? What's the next question here?
The
Number
7C.
8.
No, number
No, the
7C.
7C.
No, there's another part for this. Yeah, what is it?
Yeah.
If the water were to rebound from the wall, it will have a small velocity in the opposite direction to its initial path. After,
Oh, is the question, how will this affect the force?
yes,
Yes, okay. So, let's have a look here. What is the force if the water is brought to rest? 6 newtons. Yeah? And now the question is, what if the water is not brought to rest? How will this affect the force? So let's have a look.
Newton's third law.
Let's have a look. Let's have a look. So 2 situations. The first, F equals delta P over delta T, which equals mv minus mu over delta T. But in situation 1, one of these is 0. Which one? V. So the answer is minus mu over delta T. I'll call this F1 for situation 1. Okay? F2, what's the difference?
V is not 0.
The V is not 0, is it? So you have mv minus mu over delta T. Are either of these 0? No. So this is mv over delta T minus... sorry, I'll write that a little neater. Mv over delta T minus mu over delta T. Now, what is this mu over delta T equal to? Very good. Yeah, the F1. That's what you said. And this here, I don't know what this is. I'll just leave it there. Is this positive or negative? And no, think again. The V is the velocity after it hits the wall. Which direction is that? Left or right? Left. So what you have here is F2
Opposite.
equals a negative number plus F1. And F1 is also negative number. This will be more negative than F1 by itself. Obviously F2 will be more negative than F1 because you're adding on another negative number. So in other words, therefore F2 are bigger in size, in magnitude, yeah. We'll say the size of F2 is more than F1. So in other words, if the water rebounds, then there's more force. Now this makes sense if you think about it. If the water is brought to rest, the force of the wall has to stop the water. If the water is brought to rest and then pushed the other way, then there must be more force coming out from the wall. Yeah. Makes sense.
No, isn't the water drawing giving more force since it hit the wall and it's rebounded?
Will the what give you more force?
The water that is being
Rebounded?
pumped,
Yeah.
that means the pumping of the water has more force.
Yeah, no, the question is interesting. What is making more force? They didn't say that the velocity changes, they just say the water rebounds. I think what's happening here is in the question the water really is rebounding, but in the first part they ask you to ignore that, pretend it's not doing that. And then in the second part they want you to make it more realistic. Okay? Because you can't, like you said, the only way you could make that really happen is if you make the water travel faster maybe. I mean you can't really do anything to the wall to make it reflect the water stronger, you know? Okay, what's the next one now?
Sorry, let's.
Yeah, but what's the next one? Is there more to...
Yeah, number 8.
Oh,
Number 8. Couldn't do it at all.
okay, how many more questions are there to do here? 8?
that's all for me.
And then the
11 and 12.
11.
The 9 too.
Ah, no, I can't do them all now. Really? 8, 9, 11 and 12?
We love you, sir.
Basically,
8, 9, 11.
yes, basically.
Right, I'm not going to do any of those that seem similar to something I've already done. So, while you're writing that down, Marwan, can you read number 8 to me and I'll say yes or no to it?
during a tennis serve.
Another tennis ball question.
Yeah.
I don't know, that sounds suspiciously similar to one I just did, doesn't
No,
it?
It's not similar.
It's not similar.
It's easy.
I did it easily, but it was not.
I think it's easy.
I'll do it quickly, so. Is it similar or different? I thought so.
Similar, I think. It's easy.
Or I'll do it quickly, okay? I'll do it quickly. Right, what's the ID number? Quick.
253.
253. Alright, go for it, Marwan, let's do it quickly.
A tennis racket is in contact with a ball for 20 ms.
Yeah.
The ball of mass 0.059 kilograms leaves the racket with a horizontal
Supposed to be MS, not
velocity
MS.
of
Thank you.
horizontal velocity of 30 meters per second.
This seems like, is it even the same mass? And what's the V?
30.
The V is 30.
No, V is 0.
Oh, 0.
No, actually V is 30, U is 0.
Yeah.
Oh, the ball is at rest, and then the tennis racket hits it. Okay, fine. And what are they asking for?
The change of momentum.
Oh, okay. MV minus MU, the U is 0, so that's 0.059 times 30, right?
1.7.
1.77 kilogram meters per second. Right, what's next?
Impulse.
Impulse.
Impulse is the same.
Same.
The same. That's what impulse is.
The average force.
Ah,
Very
guys.
simple.
Yeah, very simple. Who asked me to do this? Delta V over
Class
delta T.
Class
I
rep.
don't think it was.
0.0.
Uh, what is it, sorry?
88.
88.5 newtons. Right, now I'm scrolling down to the next one. Right, what's the next one we want to do?
11.
11! What number? ID number?
442.
442.
Yeah.
Okay. Go for it.
C.
Oh, you don't need me to do A and B?
No.
So we
Thank
need
you.
to just do
Do everything? Alright, fine. Fine. Ming, read the question from the beginning.
A rocket uses a long trace into space
physics.
Go on, don't worry.
as a race by ejecting gas at high speed from its source of a rocket motor. The velocities of astronauts is 4,400 meter per second and 7,950 fifths kilogram.
7955?
Yeah.
Yeah.
So this is the upward thrust on the rocket. Yeah? Is that the first question?
Yeah.
Right, what's the number here?
The question is if the rockets have an
Initial?
initial mass of 2 multiplies
Sorry, say it again. Initial mass of what?
Initial mass of 2.0 times 10 to the 6 kg.
Thank you. Oh, is this... So what's the first question?
States Newton's.
Newton third law.
Alright, well, we know
Yeah.
Newton's third law. For every action, there's an equal and opposite reaction. Right, what's the next question?
What is the force produced on the rocket by the exhaust gas?
Right, that's actually what I wrote down here.
Yeah.
Yeah, so what's that?
2.5 times 10 to the 7.
200 million.
Yeah, 35 million, is it? Newtons. Good. And let me guess, is the next question how long until the rocket takes off? No, what is it then?
If the
and
rocket
the
has a
force
remote
and the
travel,
force from the rocket is vertically upwards.
Yeah.
What is the result force on the rocket?
Ah, okay, what's the total force on the rocket?
Yeah.
Okay, so, which will be bigger here? The thrust or the weight?
Trust.
The thrust. Otherwise, the rocket would be burying into the ground,
Yeah.
which rockets don't usually do. Okay, so that's T minus W. Sorry.
Net force.
F equals T minus W, yeah? Which will be 3.5 times 10 to the 7 minus 2 times 10 to the 6 times 9.81. What do we get here?
1.54.
Yeah.
To the 10 to the 7.
7?
Exponential.
Yeah. Okay. So, what was the problem with this question?
I think what difficult also.
Maybe the English was too difficult. Yeah? Is there anything else with this exercise, homework?
What is the initial acceleration of the rocket?
Oh, there's another part, is it? So, if that's equal to F, how do I calculate A? Well, we use Newton's second law, don't we? So it's F over M. So just take this number and divide it by this number. And what do we get?
So,
7.69 times... Oh, 7.69 meters per second squared. Huh?
7.69.
7.69 is the answer?
7/7.
Okay. Maybe it depends on how many digits you take here. Yeah, okay. So it's roughly this. Okay, is there anything else in the homework? 12. Can I see 12? Is it worth doing?
Is that used?
No.
Sorry, 13, not 12. 13.
yeah, actually 13.
Okay, fair enough. 13 actually looks like it's worth doing. So, and then after I do 13, was there any questions from the second homework?
Yes. Today, homework class.
It's looking like that. It's looking like that. Oh yes, life is difficult, I know. Right. Okay, I don't think I need to do the first part. Explain what is meant by a vector, do I? No. A steel ball of mass 200 grams falls vertically from rest at a height of 2.5 meters. Yes? And what did we say? 200 grams?
Yes.
Okay. Onto a large horizontal sheet plate resting on the ground. It then rebounds to a height of only 1.9 meters. The timing device shows that it's in contact with the ground for 1.5 milliseconds, if you look at a little clock here. So can you see what's happening? The ball falls, it bounces on the ground, and then it rises back up. Does it rise to the same height as before? No. And the reason for that is after the bounce on the ground, it loses speed. Okay. Part A. What was the speed just before it hits the plate? I'm going to take down as positive. Right, so what type of problem is that? U, V, A, T, S, U, 0, V, what we want, yeah, A,
-9.
yeah, and I'm taking down as plus. T, don't know, S, 2.5. Right, now I assume you can easily get the V for me here. Oh, it's locked. What's the V? Come on, V, what formula will give it to us? Yeah, V squared equals U squared plus 2AS, 19.62 times 2.5, square root of. Okay, so what do we get for the V? 7 point 7. Yeah, okay, fine. Now, would we lose a mark if we put a minus in it, yes or no? It's okay, you can read the question to me. Would we lose a mark if we put a minus in this? Well, what did the question ask for?
Speed.
The speed,
As a vector.
not the velocity.
Oh, so it's
So you would lose out, I think, if you put a minus in, because it shouldn't be minus, it's the speed. Right? Now, what is part 2 asking me for? Okay, so now let's look at this journey. You don't know what we want. V?
0.
0. Good. A?
9.81.
Now, would you like me to stick to using down as positive, or do you want me to switch it and say up as positive? Keep or switch?
Keep.
Keep? Okay. Well, then in that case, what's the A here?
9.81.
Minus 9.81. Oh, sorry, plus 9.81. So keeping it the same.
Because it's going against gravity.
Yeah, well, this is where it can get confusing. That's if we want to keep it down as positive,
Yes.
then the A is positive. Okay. UVAT. Don't know. Now be careful. S
1.9.
minus 1.9. If we're now saying up is negative and down is positive. You know, you see, I bet you wish you said we could switch it. Right, so, yeah.
So,
But the A here is in
Well,
negative or
hang
positive?
on. Go on.
Yeah, so the time they gave us, like, what do you...
Oh, that might be for a later part. Not necessary for now. That's the time it's spent switching between the two situations. Yeah. Yes, Bello?
The A here is it positive or negative?
Positive.
I thought we said it's negative.
Yeah, and down is positive. And which way is gravity? Downwards. What am I looking for here? The U. What gives me the U easily here? V squared equals U squared plus 2AS, isn't it?
yeah.
So U would be square root 1.9 times 19.62. What do we get for U here? 1, 1?
Yeah, check 111.
Okay, what's part 3?
What was the change of momentum of the body is compared with the
Alright, so delta P equals mv minus mu. Now, do you want to keep with down as positive? Well, I guess we kind of have to now because we've done it for the last two. So, mv. V is up or down? Up. And is that positive or negative? Negative. Actually, do you know what? I'll just write it as mv minus u. Okay. What's the m? 0.2. What's the v?
Minus 6.
Minus 6.11. Minus u. Is the u up or down?
Down.
Down. Is down positive or negative?
Positive.
Positive. And what is it in this question? 7. So, what's this, please?
Minus 2.622.
Minus 2.62 kilogram meters per second. And let me guess, the last part is what force was exerted on the ball from the ground?
yes, doesn't contact.
Yeah, so what formula do we need there?
Minus 6.2.
F equals delta P over delta T. Abdulali, this is where the delta T is used now. It is minus 2.62 over, what was the delta? 1.5 milliseconds. 0.0015. That'd be a big enough number upwards.
negative 1748. So it's 175.
Yeah. Okie dokie. Okay. So, what was the questions from the second homework then? How many? And how many homework questions were there?
2.
And how many do you want? I'm not doing both of them. I'm not.
Yeah.
Yeah.
Just the
The answer is there.
Number
Yeah.
one,
I don't have fun.
BII.
What was the problem one?
Number one B, yeah, number one.
One B? 1B. Really? That was a problem?
No, is 2 and 2 and what is only 2. There's one question that's 2B.
Where is BII? 1B.
Did you hang on? So which one do you want me to do? Which part of the question do you want me to do?
Me is 1BII.
The last part in question 1.
Yes.
Yeah. Yeah, that's fine. Anything else? You said 2, is it?
You guys say so.
2.
I just want him to explain that.
2. Are you sure, David?
No,
Did you look at the answer?
It was 1B.
1B.
Yeah.
Yeah, okay. Right, can I scroll down? So, if 10 killing... Guys, what's wrong? Are we looking up, please? David?
No, like I wasn't done.
Huh?
I wasn't done, so I just wanted to copy.
Oh, okay, well, just look up for a moment, please, and then you can copy. Can I scroll down? Yeah. So, I'm doing the last part in question 1. If 10 kilonewtons is the maximum load that can be safely lifted without exceeding the maximum moment about x, when d is 30, determine the maximum safe value of d when the crane is lifting a load of 20. So, what they're saying is, here's the crane, the maximum load here you can have is 10,000 Newton weight. Okay? And the distance here is 30 meters. And then they want to know what distance would you need to make the crane at most if you want to use a bigger load of 20,000 newtons. So before we continue, this situation here represents the maximum turning force, okay? If this had more weight, then this arm would snap as it tries to get turned. Alright? So, this weight is bigger, so we have a problem. Intuitively, what would we need to do to this arm? Increase it or decrease it? No. Decrease it. Because if you imagine, use your imagination, if you make this longer and you put a heavier weight on it, would it be easier or harder to snap the arm? Easier. Okay? So I'll call this distance here d, and the trick here is the turning force in this situation, which represents the maximum turning force, has to equal the turning force in this situation, which represents the maximum as well. So in this situation, the maximum turning force is 3, 0, 0, 0, 0, 0. That's equal to d 20, 0, 0, 0. 1, 2, 3, 4. 1, 2, 3, 4. D is 15 meters. Well, that seems obvious, doesn't it? If you double the maximum weight, then to balance the system, you'll have to half the lever length. Yeah. Super tutorial.
Thank you so
No,
much.
yeah. Pleasure. Okay, well, we might as well start the maths class, huh? I mean, I'm not going to get anything done in 5 minutes.
Oh God.
Yeah, you're telling me. Right. You can close this? Yeah.